Hello, we're Team 15, and this is our lead detection device.
Hi, I'm Jake Murphy from Rutgers University, class of 2023.
I'm Taylor Parody from WPI, class of 2022.
And I'm Erin Smintek from the University of Delaware, class of 2024. Our client statement is to design a device that will notify the user if there is lead detected in the water being tested. The goal of this device is to help ensure that the water is safe to consume and won't cause lead poisoning. This product should be inexpensive to make and easy to use.
Lead contaminating water. Lead can enter the water supply due to corrosion, which is the dissolving or wearing of metal from pipes and fixtures that transport the water. Maximum contaminant level for lead is 0 due to it being a toxic metal and harmful to human health. One of the most recognized events involving lead contaminated water is the Flint, Michigan water crisis in 2014. In overview, lead poisoning is caused by a buildup of lead in the body over a long period of time, which can lead to serious health problems. It's very common for people to have lead poisoning and not even know of it because the symptoms don't appear until there are dangerous amounts in the body. Children are most at risk of getting lead poisoning. They can have serious long-term health effects on them. Lead poisoning can cause developmental delay, learning difficulties, fatigue, abdominal pain, and more. Adults can also get lead poisoning, but it's less common. The symptoms for adults are high blood pressure, joint and muscle pain, difficulties with memory or concentration, headaches, abdominal pain, mood disorders, and it can affect men's fertility and cause miscarriages for women. Existing solutions. A current solution for lead detecting lead in drinking water after collecting a sample of the water is through a process called inductively coupled plasma optical emission spectroscopy. This process includes the usage of 60 different 50 milliliter vials containing calibration, customer, and control samples. The machine uses an arm to suck the samples out of the vials and into the body of the machine. Here, the samples are changed into a vapor, which is then excited by a plasma torch, hence creating an electromagnetic field. This field excites the atoms in the samples, which will cause each element to give off different wavelengths. Then the wavelengths are analyzed by the machine to see if the lead is in the sample. This is obviously a long process that cannot be done by the average person at home and can take a considerable amount of time due to the volume of customers and having to send the samples to the lab. This is why it's important to create more solutions for the average person to make sure their water supply is safe to drink.
Our 4 goals for this project was to have a device that can accurately detect if there's lead present in the water, a device that's inexpensive to make, a device that is easy to use, and a device that is safe to use.
We designed a thin strip of paper with a chemical coating of nitrate and sulfuric acid. When the strip comes in contact with water that is contaminated with lead, the chemicals will react with the lead to form a bright yellow solid that will be easy to see and be a clear way to see if lead is present in the water.
This is the CAD design for that device. At the bottom of the ramp is where the paper with the chemicals on it would sit, and it would be all covered by a clear glass screen, so it's safe to use, and the reaction will be able to see what's happening after you place the water in the little opening, and it'll go down and react. And these are just the drawings that have the measurements of all the parts that we created.
For the future of this project, the next steps would be to actually build a prototype to be able to test our detection device. Future studies should also be done to ensure that our product is safe to use. A cost analysis of the cost it takes to build and assemble our device should also be completed.
Here's our works cited, and we just wanted to thank the WPI BME faculty for running this program. Thank you so much.